right, Algebra 2, we're moving through Chapter 10, and we're going to start talking about exponential functions. And I know you've heard this word a lot in the news, but we're going to start slowly. Exponents are logarithms. Exponential functions are just logarithms. So a lot of people freak out when they hear the word logarithm, but remember, exponents and logarithms are the same thing. We're going to start in lesson 10.4, and we are doing definitions of logarithms. And don't freak out, logarithms are just exponents. So we're going to compare the exponential form to the logarithmic form. Our essential question today is, can you define logarithmic functions and learn how they are related to exponential functions? So our whole goal today is to see this and how this is happening. So I'm going to give you a couple little hints that I like to give. Notice that 2 to the third power is equal to 8. And the way we write that as a logarithm is log base 2 of 8 equals 3. So the first thing I'm going to do is write out the wording to this. Log base 2 of 8 is 3. And I'm also going to show you how I do this. I always tell my students, remember, you're taking this 3 and it's jumping inside. So this is saying 2 to the third power is 8. And if we had to go the other way, I would say, hey, from exponential to logarithmic form, we would jump out. So log base 2 of 8 is 3. Let's look at the next one. 4 squared is 16. Log base 4 of 16 is 2. So remember, we're just jumping this guy in here to say 4 squared is 16. Here's a fun one. Anytime I have a 1, log base 7 of 1 is 0. Remember, anything to the 0 power is 1. So anytime you see that 1 in this position right here, we know it's going to equal 0. And let's look at a couple more. 2 to the negative first is a half. So remember, this negative right here tells me to throw it on the bottom. And negative 1 is equal to log base 2 of 1/2. All right, example 1 is just going to say, hey, let's make this from log form to exponential form. So they're saying express log base 3 of 81 equals 4 in exponential form. So I'm going to take this 4 and put it right in the middle. And I always think saying base, log base 3 helps, because you know that the 3 in this case is the base. We're going to make the 4 the exponent, and that's equal to 81. And that is true. 3 to the 4th power is 81. And let's go ahead and express 5 to the 3rd power equals 125 in logarithmic. And again, we can go ahead and jump this guy to the outside. Log base 5 of 125 is 3. So I'm going to skip around a little bit to not go over every single example. This is saying log base 1/9 of the 4th root of 3. And we're trying to figure out what this is. So what this is really asking is, we're going to make this equal to x. They're saying 1/9 to what power is the 4th root of 3? Well, goodness, doesn't this look like a mess? The first thing I have to do is take the radical and make it into an exponent. So remember that this is 3 to the 1st power. So I can write this as 1/9 to the x power is equal to 3 to the 1/4. Our next step is we have to go ahead and make the 9 in the same base. Well, I know this is saying 1/3 squared. All of that to the x is equal to 3 to the 1/4. We're not there yet, are we? I can bring this 3 squared to the top by making it negative. 3 to the negative 2nd to the x power is equal to 3 to the 1/4. Still not there yet. But what I have to do is, since now that we're in the same bases, I can pull out the exponents and make them equivalent to one another. So I'm going to do that. -2 times what is equal to 1/4. In order to get rid of the -2, it is being multiplied, so we have to divide. And I know that what I do to one side, I do to the other. And x is equal to -1/8. All right, I've totally jumped to some harder ones because I wanted to look at a little bit of practice. So this is in the practice part of your notes. I'm going to start with this one right here. It says log base 2 of 4 times the square root of 2. And remember, if that's equal to x, what this is really saying is 2 to what power is equal to 4 root 2. Well, once again, I need all of these in the same basis. So I'm going to hone in here and let's see what's happening. 2 to the x looks like that's the base that we need. 4, I know, is 2 to the second power. And the square root of 2 is 2. And remember, this is a 1. I'll write it in a different color. This is a 1, and this is an invisible 2. So that's 2 to the 1/2. When I multiply, I add. When I multiply, I add. So this is saying 2 to the x power is equal to 2. Well, when I have the common denominator, I could write it like that if you want me to. I have 5/2, because 4/2 plus 1/2 is 5/2. And I could go ahead and show my answer, because now that we have the same base, the exponents are equivalent, and x looks like it's equal to 5/2. All right, so that one was a mess, and this one looks like this one's going to be a mess as well. So I'm still moving into the practice part of your notes if you're going along with notes. This is saying 6 to what power is equal to 36 to the, remember this is 1/3. Well, once again, I have to have the same base. So I'm going to write it right over here. 6 to what power? Well, I know that 36 is 6 squared, and that's all to the 1/3. So this one doesn't look as bad because now I'm in the same base, but I have to go ahead and take care of this power to a power first. So my next step will say 6 to what power? Well, when I have a power to a power, I do multiply. So this is 6 to the 2/3. And if you know, x is equal to 2/3. Because we can just pull out the exponents when the bases are equal. Great job, Algebra 2.